Hello, scientists! As you can see, it's me, Professor H2O, and welcome to our lab. Today in the lab, we're doing something a little nutty, aren't we? This is not something I wear usually, but it is today because today is all about the science of wizardry. So we are going to do magic today, but being a scientist, it's also going to have some science in there, so we're going to do scientific magic, meaning I'm going to make it look like magic, but really there's some science in there too that can explain all of the awesome things that are going to happen today. So I am Professor H2O. H2O is just a silly word, fancy scientific word for water. I love water. I love drinking water, doing experiments with water, swimming in water, boating in water, rain, everything. So today we are going to do some experiments with water, and it's going to be a blast. Are we ready? Okay. So as every good scientist / magician is, I have my magic wand. Unfortunately, my first trick was to try and get this can to move. You think we can do it? Well, let me make this harder. I want the can to move, but I don't want to touch it. I just want to put down my magic wand. Oh, here we go. Look, we did it. No, we didn't do it. You saw me maybe touch the can and I rolled it. That is not really magic, is it? So they say that the wand chooses the wizard. So maybe this just isn't my wand. Maybe we should try something else. Maybe this is my wand. What do you think? Let's try it out. No, it's just rolling. All right, ready? Nothing. Maybe if I turn it on. Still no movement. Let's try one more thing. I think I know just the thing. It's calling out to me. My wand is being drawn to me like magic. Let's see. It's pretty fancy. You want to see it? Very expensive. Here it is. I just feel it. I hold it and I feel the magic within it, and I know that this is going to be my wand. Are we ready? Let's see if it works. Still nothing. But like I said, I'm a scientific magician. Maybe this just needs a little bit of science, huh? What I'm going to do is I'm going to take this and I'm going to put on a glove and I'm going to make static electricity. Now, electricity can be dangerous, right? Have your parents ever told you not to play with electricity? That's probably good. We're going to make static electricity. And static electricity is the same as you getting shocked going down the slide. It may hurt a little bit, but it's not going to do anything that's going to put you in some real danger. All right. Now we've got it charged. If you listen really closely, you may be able to hear it, a little bit of shocking. I don't feel anything though. All right, let's see if we can do it. Did you see it? Check that out. I told you I was feeling the magic on this one. Let's see. How cool is that? So with my static electricity, I am pulling my object and it looks like magic. Pretty cool, right? But I really want to put my magic to the test. I want my can to roll uphill. What does that mean? That means it would be a lot easier if I put my can here and just watched it go, right? That'd be pretty easy. There's really no scientific magic with that one. It's just gravity. But I want to try to make my can roll uphill with my magic wand. Do you think we can do that? I don't know. I don't know if my magic wand is that powerful. We'll have to wait and see. So let me charge it up a little bit more, get that static electricity going. All right. We ready? I hope we get it. Who thinks we can do it? I think we can. I think that we can really, if we got a little bit of momentum, built that momentum up. All right, let's go, let's go, let's go, let's go. Check that out. How awesome is that? This is a very powerful magic wand. It shows you, don't judge anything by the way it looks. It doesn't look very fancy, does it? It looks a little dirty, honestly. My other magic wand looks a little cooler. But this guy, this really has the magic of science. Let's see what else it can do. So we've already made our magic defy gravity. The can rolled over my notebook. Pretty cool. Let's see if it can do something else. This trick I've been dying to try, and I think you guys are the perfect ones to try it on. Look at this contraption. Pretty cool. All right. So what I'm going to do is I'm going to try, I moved a can. That was pretty impressive. Let's try and move water. Move water. That sounds very difficult. That sounds a lot harder than moving the can if you ask me. But we're going to try it anyway. What I'm going to do is I'm going to pour water in my top cup. It's going to drip down in the bottom. And I'm going to take my magic wand. I'm going to charge it and try to move the water. This is a true test of my magical powers. Should probably charge it first. Make sure it's good and ready. Get that static electricity going. And it's pretty cool because this is something that maybe you can try at home. If you have a little tiny piece of PVC like this, maybe you can try and make your own magic wand. Just don't hit anybody with it, okay? Sounds good. And I do have to be very careful because if the static electricity hits the water, I lose all my charge. So I gotta be careful not to hit it. All right, so I'm gonna put my water in the top cup. It's gonna drip through the hole in the top cup to the bottom one. Oh, you hear it? I hope you heard that because that's a little... So far, so good. Now let's see if I can move it. All right, are we ready? Check that out. This wand truly does have magical powers. See, now that it's wet, it loses its static electricity. Let's see if I can get one more charge in there before it all runs out. Maybe try the other side. Hurry, 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 hurry. I don't know, I don't hear it charging. There we go. That is so awesome. And again, this is just a normal PVC pipe. So maybe you can try this out of your fountains or your sinks at home. I bet your dad or mom has some PVC laying around that you can try it out with. Just ask them first. And check for spiders. Spiders like to make the PVC pipes their homes inside. All right. Pretty awesome. So we will put our magic wand away because I have one more magic wand to show you. This guy didn't really do a whole lot. This guy is awesome and powerful, but he is making my arm a little tired. He's heavy. All right, but I have one more to show you. Let me move this away. Wow, that's a lot of H2O. Oh my goodness. Move this, make a nice clear space. We'll put this over here for right now, and we will carefully slide this out of the way. This is called a ring stand. It's pretty awesome too. All right, you want to see my last magic wand? This is one of my favorite magic wands. And again, it uses the same concept. It uses static electricity to move objects. But today, we're not going to move water with this guy. We'll probably move the can, just like we did with the PVC pipe, and I've got another special thing that it can move. All right, you ready to see? Abracadabra. Nothing. What do you think I need to do? Press the button. Professor H2O, it's been a long day. All right, ready? Let's try again. Come on, little can. There we go. I have to hold it to the top to let gravity help me out. Ooh, you hear a little shock? See? Static electricity. Awesome. So, that's pretty cool. This is called a fun fly stick. And they are awesome. Let's make some things fly, why don't we? Maybe levitate. We would be excellent scientific magicians if we can make things levitate. You think I can make this can levitate? Nope, that's not the answer to that. All right, so let's try. I've got all these fun flyers that we will try to make levitate. What should we do first? How about we should start small? Are we ready? Let's see if we can make this go. Come on, though. Let's try again. Scientists never give up, right? If we don't get the results we want, we just try again. One more time. There we go. Look at that. Is it magic? No, it just looks like magic, doesn't it? It's science. There we go. Now we're going. How cool is that? All right, let's try another one. This one's probably a little bigger. Wow, this one's like a sphere. And you notice that even when I don't press the button, it still levitates. And that's because it's built up quite a bit of static electricity charge that it's enough to make this really go. Let's see if I can make it. You see it? Check that out. It does sting a little tiny bit. I can feel it. It's like it's grabbing on. How cool. I love this little sphere. I think that it's really cool. I hope you guys can really see how awesome this one is. All right. So this guy is a butterfly. Let's see if we can make him fly. How beautiful. Flying through the air. And last but not least, here we are, the big kahuna. All right, let's see if we can make it go. Whoa, what? Wow, it reminds me of a planet. Let's see if I can make it twirl. Oh, it's like the ocean. I know, right at you. I'm so sorry about that. Let's try. I hope you didn't get shocked in there. See, now there's enough charge that it's really starting to shock me a little bit. All right, let's try one more time. Fly. I am very much its favorite thing right now. Pretty cool, right? I love these little wands. So now I've showed you 3 wands. We showed the Amazon wand. Not a whole lot that it's doing, but it's good for show. If I want to show up and really impress some people, I might bring this one along. I showed you my PVC wand that can move the can, move water, all kinds of stuff. And then there is the fun flyer. I do have a question though. I've never tried it, but I think that we've got a good opportunity. I wanted to know if my fun flyer could also move the water. My pipe did, and it also moved the can. Remember? Do you think it can move the water too? You think it's as strong as the PVC pipe? We have a couple minutes. Scientists always like to ask questions, right? So if you have a question and it's easy to find out the answer, why not? All right, we'll try this one time and then I'll try to move my water with the fun flyer. And then we will move on to our next class, potions. Ooh. All right, here we go. Make sure I don't make a giant mess. All right. So this one I don't have to charge. What it actually has inside are these bands that go round and round and round and round and round, and that's what makes the static electricity. Whereas with the pipe, I had to take the towel and I had to do it myself. All right, but let's see if this works. You think it will? No? I don't know. I don't even know the answer to this one. Let's find out. It is working. Look at that. Oh, man. All over my tablecloth. Again, the water is killing the charge, but if you saw, it definitely did work. So that's good to know for next time. All right. And now, potions. I do love potions. Let me stop this fountain from going real fast. Probably just plug the hole. I think that'll work best. I would clean up this little area, but with potions, you never know what's going to happen. It could get messy again, so there's no point. Which one of those wands was your favorite? I think that I still like my PVC wand, even though it really gave me a workout. My PVC wand is still my favorite, I think. All right, so we're gonna start off with a potion. That's one of the first ones they teach you in Science of Wizardry class. Are you ready? As with everything with Nutty Scientists, we do love to make everything colorful, so we'll be sure to add some colors. Okay, so for this potion, we're gonna use some bottles like this. We're gonna use vegetable oil, some secret tablets that I will talk to you about in a second, and of course, food dye. Unfortunately, we have 4 colors in 3 bottles, so one of these colors isn't gonna make it. I don't know, we'll have to make a choice. All right, the first thing we wanna do is we're going to make, I'll tell you what we're gonna make because they're super awesome. We're going to make scientific lava lamps. You guys know what lava lamps are with the bubbles that come up, and it's really, really awesome. I'm excited to show you. All right, first thing we'll do, we will add some water. We're gonna add water to each of our bottles. Hopefully I have enough. If not, I may have to go get some more. One, 2, 3. All right, so we could add the food coloring now because we want to dye our water, but I want to show you a couple different ways it can happen. So what we'll do, we're not going to use yellow, I think, because yellow is going to be the hardest to see. We will add, let's see, we'll add color to 1 or 2 of our bottles now. Get that diffusion going. If you know me, you know I love diffusion. Dancing through the water, get that color moving. And then let's add 1 more. And then the third one, what we'll do is after we add our other ingredient, we'll add the food coloring and you'll see the difference. Get some blue. All right. So some of you may have heard from either school or your parents that water and oil don't mix. Normally, like food dye, you put a product in water and then it mixes around and they combine and they make one thing. But oil, that doesn't happen. What oil does is because it's a different density, it just sits right on top. So let's see. Oh, I should probably do that a little bit slower. Built up in my funnel. Now watch as that separates out. How cool is that? All the oil is floating up to the top. You're about even? We're close. We'll give a little bit more to the middle one. It doesn't really matter if they're even. I just like all my bottles to feel equally loved. All right. Awesome. So now I want to show you what happens. Well, if you look really closely, all the water is separating to the bottom and the oil is bubbling up to the top. I'll even scooch this right in. Check that out. How cool. All right, but now I'm going to show you what happens. The red food dye has to go through the oil all the way to the water, whereas the other ones, the food dye was just mixed right in. So let's see how that goes. Ready? Check out how it's not dyeing the oil. It's just sinking down in little blobs all the way to the bottom. All right. Maybe then once it's down there, it'll really, oh, there's some oil stuck at the bottom. All right, come on, dye that water. Oh, we'll get it moving. Don't worry about it. You'll see. So here we go. We are going to add Alka-Seltzer. Alka-Seltzer is the medicine that you may take if you have a little stomach ache. If your stomach's feeling a little weird, you may take these to help your body produce bubbles and maybe help you burp or something like that. So we are going to use these for our lava lamps to make some bubbles. Are we ready? Now we could use half a tablet or we could use a whole tablet. I wonder which one we're going to go with. How about a whole one? Just for you guys. All right. Let's see. You see it bubbling? How cool is that? We're really getting that lava lamp going, that lava lamp feel. It sure looks like a potion, doesn't it? We can even add another half a tablet. Nothing really bad is going to happen. Let's see. And then I'll show you with the light underneath, and you might even be able to see it better. Wow. Check that out. That is so awesome. And you see that the food dye did eventually get down to that red water. All right, let's try and shine one under the light. I don't know which one we should show. How about the blue one? Does that help you see it? How cool. Now, if you look, the Alka-Seltzer is bubbling up, and since that water and the oil don't mix, they're just making little tiny bubbles of the oil. So if you asked me what I wanted to do with my Saturday, this would be it. I would like to make lava lamps all day long and just watch them. Let's see, which one's still going? Ooh, that one looks cool. Let's add a little bit more Alka-Seltzer. Why not? Wow. And then we'll show you the green one, and then I'll move on to my next potion. I sure hope that you guys can see this as closely as I can, because these are awesome. This one looks neon. There they go. I like that it also changes the color of the oil, it looks like. Even though the oil still stays the same color, with the light, it looks like it changes the color of the food dye. That is really cool. I will try with one of them, I guess the blue, because that's the dye that's on the funnel. I'm going to fill it a little bit more with oil, and then we'll try one more before I move on to my next potion. All right, let's get that Alka-Seltzer in there. Thank you, Mr. Green. Awesome job. All right, so this one's all the way almost to the top with oil. Sure hope that doesn't fall over. That'd be a mess. That'll give the bubbles a little bit longer way to travel. How cool is that? There we go. Look at him go! It looks like an underwater volcano. Oh no, there we are. That's why we don't add more Alka-Seltzer, right? It's okay. Alka-Seltzer is not going to hurt anything. But that was cool for a second though, huh? All right. Cool. That's a really fun potion. That's one of my favorite potions that we learn in our beginner's potions class. You ready to see an intermediate potion? All right. Well, let me move this stuff out of the way. Wow. I wish you guys could see this too. It left a really great mess on my tray. It's got some oil and then some blobs of blue. It's pretty cool. All right, let me move this out of the way and clean up my mess for a second. We don't want this potion mixed in with our next ones. You never know. Did you also know that potions actually use a lot of math? That's right. We can't just throw a bunch of stuff in there because then things explode. There we have it. All right. We ready for our next one? So for my advanced potions, I am going to need to be a little bit more careful. This one was fine. Even though I got Alka-Seltzer on my hands, it didn't really bother me. This other stuff, I'm even going to take my magic hat off just in case something was to happen. So, doesn't look very dangerous, does it? It's just got some more chemicals that are a little bit more intense than our Alka-Seltzer. So I'm going to just make sure that nothing is going to get hit with it. Just in case something happens. Always be careful, right? All right, so at the School of Science and Magic, we have these little frogs. And these frogs are pretty smelly. They have this horrible toad's breath. So what we try to do is we try to make a toothpaste for our frogs, nice and colorful, so that maybe they can brush their teeth with it. It warms their little mouths up in the cold of winter, and maybe makes them smell a little better too. All right, so that is what I'm going to try and create for you today in my cylinder here. I have all of my my materials pre-measured, so I'll tell you what they are as they go in. All right, first off, I have 2 of these, which is H2O2. Now I'm H2O, but this just has a little bit extra oxygen in it. And I'll show you the bottle so you'll see it. See? Where is it? Hydrogen peroxide, H2O2. So, let's try it. We'll add that in first. Hopefully nothing happens until we add our catalyst, which is later. And catalyst we add to really get things going. So we're gonna add about 50 milliliters. I told you there was math involved. 50 milliliters of H2O2 hydrogen peroxide. I'm wearing the gloves just because this stuff is pretty powerful. It's not like the stuff that you put on cuts. That's hydrogen peroxide too, but it's a lot more diluted. There's more water in it to make sure that it doesn't hurt you. It still burns when you put it on cuts to clean them, which it's supposed to, but this stuff's a little bit more intense. This stuff, the most dangerous of them all, dish soap. Have you ever gotten this in your eye? Doesn't feel good, does it? So we'll add that in there. And of course, our frogs are not going to use the toothpaste unless it's fun and colorful, right? So we've got to add our colors. And I've got these really cool neon ones. Mix that up a little bit. What we're going to try to do is put our food dye down the sides, and you'll see why if this works the way I want it to. Get some blue. Some pink. Might as well just go for it to make these frogs happy. The more they use this, the better, because whew, do they smell. Some of this green. It's not really sticking too well, but hopefully you'll see this effect still. And this purple, if I can get it open. If not, we'll have to go without, oh, there we go. Okay, this looks fantastic. It looks like a nice little rainbow. Pretty cool. All right, the last thing we're going to add is hopefully our catalyst, potassium iodide. All right, we ready? Let's see if it works. Here we go. Go little toothpaste, go little toothpaste, go little toothpaste. And there we have it. Do you see it steaming? How awesome is this toothpaste? Do you think my frogs will use this? Wow, it is rainbow bright. I wish my toothpaste looked like this. And it actually is warm from the reaction. It creates heat. Again, another thing I could just watch all day. I just love potions, don't you? Wow, let me move this closer to make sure you get a really great view. And I'm actually going to turn it so you can see this. Look at that. How cool. I wonder how long it's going to go. We won't wait for that, but I would if I was just here by myself. If you guys weren't in the lab today, I would just sit here like this all day watching it. All right, but let me feel it. I also like that there's some, this part over here is green and purple, whereas this part's a little red and then the blue up top. Let me feel it. Definitely hot. Actually, it's quite hotter than I thought it was going to be. Yeah, it's kind of like if you're heating up water, if your mom's heating up water for tea or something like that, it feels like that. It's not boiling, but it's definitely hot, like it would burn you if you weren't wearing, if you hold it or grabbed it. Wow. Is it okay if I just leave this behind where you can see it for our last experiment? I would really like to see how this turns out because it's just so pretty. I love science. See? math's not so bad. Creates things like this. Pretty cool. All right. Awesome. You ready for my last experiment? It's pretty cool. All right, you want to see a real magic trick before my last science experiment? On the count of 3, I'm going to snap my fingers and then everything will be cleaned up. You think I can do that? All right, ready? 1, 2, 3. I can't believe that one worked. I don't even recognize the place with how clean it is. All right, so I do have one more experiment to show you, but I do have to also show you this thing. I can't stop looking at it. It's almost completely covered. Pretty awesome, huh? Really cool. All right, the toads are gonna love that. All right, so for my last experiment, we had, well, a lot of science is just finding solutions to problems, right? If there's a problem, you need something to fix it. So scientists, engineers, people in STEM, they find a product to fix it, right? So we had a problem at the Scientific School of Wizardry. They're called hamsters, mixed with lions, lamsters. So I've got a picture for you. But has anybody ever watched Harry Potter? And you've seen the little plants that they pull out of the ground and then they scream? Yeah? Well, that's what we had. Lamsters. Pretty crazy looking, right? But they were a nuisance. They let out these super loud screeches. So what we had to do is we had to find a way to mimic the sound so they came to us and we could study them and find a way to maybe calm them down a little bit because it was really interfering with our classes. So we did find a way using science to imitate their call and bring them to us so that we could make a study of them. And as you know, nutty scientists, it's very hard for us to get through a show without dry ice. So I do have one dry ice experiment to show you that is going to show you how we imitated the lamsters' sounds. Are we ready? If you haven't seen dry ice before, you're in for a real treat. I also thought we would put some in our cauldron because this is science of wizardry, right? We gotta have a cauldron in there somewhere. Get my gloves. Have to wear my gloves and my glasses because dry ice is so cold that it'll burn me if I touch it with my hands. So, I'm gonna use this piece. Let's try that again. There we go. Now we feel like we're in the mood for science and magic. All right? But I'm going to show you. As you can see, it's sublimating. It is getting rid of all that gas because the water is heating the dry ice up and it's turning into a gas. It's called sublimation. Because all this is compressed gas. Looks like I'm cooking up something really great, huh? All right. So, to make our lamster noise, to call the lamsters in, we're going to use dry ice and then this spoon, which is metal. So we want to warm our spoon up. And I told you dry ice is really cold, right? It's 100 degrees below 0. So we have to warm this up, and then when the hot metal touches the dry ice, it makes the sound of the lamsters. Are you ready? All right, listen close and you'll be able to hear it. What do you think? It sounds like they're flying through the air, huh? Like eagles. But we did use this to call our lamsters so we could learn about them. And that is how we called the lamsters so that we could study them with our favorite dry ice. You see it? Sublimating, releasing all that gas. Now I could just put it back in its cooler, or I could put it in my cauldron and really get it going. What do you think? I agree. Might as well. Looks like it's filing over, right? Watch this. Pretty cool, huh? That's why we love dry ice. All right. Well, I hope you had some really great experiments today. I hope you had fun. I hope you learned something. You learned about my magic wands. We moved some cans. We moved some water. We did our potions, including this beautiful toothpaste that we've created. One of my favorite potions of all time, and our lava lamps. Those were really cool too. And then I told you about the lamsters and how we solved our problem using science. Thank you again for watching, and I hope to see you soon, okay? Bye!